Hey guys, it's Mrs. Sherman. So today I'm going to just give you a quick lesson about simplifying rational expressions. If you can remember from back in the day, something is rational if it is a fraction. So basically we're going to have a bunch of fractions that we're going to be simplifying, which sounds like a blast. So let's kind of just go back and remind ourselves of some stuff from the past. Just if I asked you to simplify the following. If I just said, hey, I'm giving you the equation 35x squared over 10x. And I said, simplify that. You would say, oh, okay, we're just really trying to reduce it as much as possible, seeing if anything cancels, stuff like that. So if I was trying to reduce 35 over 10, I could do that pretty easily because those are both divisible by 5. So basically, you're just dividing out your common factors. That's the main goal. What do they have in common? Divide that out. So I'm dividing out 5 from the numbers, and that would give me 7 over 2. Okay. And then I think about x squared and x. And what do those have in common? Well, this, if you think about x squared, it's x times x. That has two x's involved, and that has 1. So they have 1x in common. So I can divide out an x. If you want to kind of do it like that, I'm going to not do that in the future, but just to show you what we're doing. So that would just cancel to 1, right? 2 times 1 is just 2, so we're all set. And if I have x squared, but I take and divide an x out, I would just be left with x. So that would be your final. So our main goal when we're dividing, once again, is to just cancel or simplify, reduce common factors in our fraction. So let's look at another one with just kind of a few things going on. 28 into the third. You would say, hey, I want to reduce this. 28 over 28, that one's easy. That's just 1. You don't even really have to put the 1, but I'll go for it just for fun. And then if I have n to the fourth over n to the third, if you actually also remember back, we were kind of talking about dividing here, but if you remember back to your properties of exponents, this is one of those properties because when you divide, you subtract exponents. So 4 minus 3 gives me n to the first, or just n. So that's my final answer for that one. So it's kind of bringing in a few things that you guys have done in the past, but it's always just a good reminder since it's probably been a while since you've done these. So let's try just one more kind of similar to that, and then we're going to look at kind of the next thing because we're going to relate it back to our good old factoring for the next part. So if I had a problem like this, I'd say, okay, I want to simplify this. Okay, can I reduce it? Does anything cancel? Stuff like that. Sorry for the weird shadows as well. But I look at my kind of coefficients first. 36 over 40, I'm going to reduce. They are both divisible by 4. That would give me 9 over 10. And then from here, I'm going to look for common factors. In this case, I can use those kind of properties of exponents, and I would just be left with x. You can either put the x next to it. I usually just put it with the numerator, but that's the thing. So that's the main idea. Okay, we have these fractions. We want to reduce them or simplify them. So let's look at how that relates to what we've been doing with factoring. Good old factoring, we love it. If I asked you to simplify, let's just say 5, p squared plus 20p plus 15 over p plus 3. Okay, so we're saying, oh, simplify that. You're probably saying, well, that doesn't look the same. Now we have all sorts of terms and addition signs. So just as a reminder, we call this a quadratic trinomial. This is a linear binomial. I can't just start being like canceling stuff. So when I think of this as a binomial, these are kind of together. So they're stuck together. You can't just pick one or two things. When you have that addition, you have to keep them together as a binomial. What we can do is say, well, if I look at that numerator, I think that's factorable. So let's factor that and then kind of just see what happens as we go. Before I get into, splitting it up, I do notice that there is a GCF, so I'm going to take that out first. So I have 5, and then that's p squared plus 4p plus 3. Okay. I'm still doing this. Once again, you can't do something like, oh, those 3's canceled. No way. This p plus 3 is a binomial that stays together. So I'm going to now factor that. Make sure the GCF stays there. You can't kind of just get rid of it. So when I factor that, that would be, I'm just going to split up my p's. 3 and 1. I add them both. Okay, beautiful. Okay, so not bad. So I get here and I'm saying, okay, well, what's my main goal still? My main goal is to cancel any common factors and reduce anything that I can. What I notice is I have a p plus 3 and a p plus 3. Those are common factors. So you need the binomial to be the same, which it is. So once I notice that, I can cancel those. So that's kind of delightful. And then whatever is left over is your final answer because nothing else is going to cancel. So my final answer to this would just be 5 times p plus 1. And that would be my simplified version of that. So your main goal for these is, okay, I have a bunch of stuff going on. Can I factor? Is there a GCF? Little things like that. And then once everything is in factored form, do any of the terms cancel? So let's try another one or two here and see how we're feeling. But main goal is factor first, cancel later. So if I have something like x plus 9 over 5x squared plus 35x minus 90. Okay, so I can't just start canceling stuff. I have to factor first. I can't do anything to the numerator, so we're kind of all set there. But the denominator, in this case, there is a GCF. It doesn't happen every time, but it's kind of just random. X squared plus 7x, what's 90 divided by 5? Minus 18. Okay, I'm going to keep going with my factoring process here. GCF on the outside. That will give me what? X plus 9, x minus 2. Okay, so we're factored all the way. Now my question is, what is going to simplify? What's going to cancel? And I notice x plus 9 and I notice x plus 9. Those are common factors. That's going to cancel. And we're going to have a final answer. Just be careful on this one. Don't be like, oh, that canceled. So I'm left with this and this, and I'm all set. These are in the denominator. They have to stay in the denominator. And if your numerator canceled, you're just going to put a 1 there. And that would be your final answer for that one. So just little things that pop up. Always look for GCF. Always look, can I factor something? Once things are factored, from there, what can I cancel? And then what would I be left with? All right, let's try another one. I'm just trying to find random ones here. So let's say we have, sorry, I'm trying to find a nice, oh, let's just do this one. This one isn't bad, but it's good to just see different things happening here. Let's do this one. It's kind of a basic one, but just as a reminder, I feel like sometimes we always want to like try to do the most work as possible. This one, you just kind of look, okay, what can I do? Nothing cancels right now. If I look at the top, the numerator, there's a GCF. Bottom, I can't do anything. I see a common factor. I cancel it. I get my final answer. So that's that. So just as a reminder, just for things that you're looking for, that's kind of the main idea. And we'll go from there. So over the next few, or today / tomorrow, you're going to kind of be practicing with this. So go back and make sure that you check what you did. And then we'll be adding on to this as we go. So we'll be doing some fun stuff with rational expressions like multiplying and dividing and adding and subtracting, and it should be a blast. So we will talk about that as we go. Please let me know if you have any questions, and have a nice day.